This time we want to use inverse functions. Now please remember that we have already been using some inverse functions. The difference here is we're going to use them on the calculator. We'll solve some equations where the answer is not one of the ones we know from the unit circle. So let's solve 2 cosine squared of x plus 7 sine of x equals 5. All right, the first thing we have to do is make a substitution so that we get everything in terms of the sine of x. Collect like terms and factor. Okay. So we'll wait here a second while everything gets collected and I get the right signs on things. And I'm going to multiply through by a -1 since I can factor easier when I do that. All right, we've got 2 sine of x equals 0, -1 and -3. So 2 sine of x minus 1 equals 0. 2 sine of x equals 1 implies that x is 1/2. Right? Sine of x is 1/2. Oh, duh. All right, so if the sine of x is 1/2, then the arc sine of 1/2 is pi over 6, since it's in quadrants 1 and 2, so it'll be pi over 6 plus 2n pi, and 5 pi over 6 plus 2n pi. Now, we have to do sine of x equals 3, right? And x is equal to the angle whose sine is 3, undefined. So we're finished with that one. Let's try another one here. Cotangent squared of x minus 9 equals 0. Oh, that's easy to factor. That's the difference of two squares. So the cosine of x minus 3 equals 0. Cotangent, I'm sorry, I keep saying cosine, I mean cotangent. X equals the arc cotangent of 3. Cotangent of x equals minus 3, so x equals the arc cotangent of minus 3. Now we need the calculator. So here we go. Let's look at the TI-89 first. All right, now first of all, it does not have an inverse cotangent on the main screen. So you're going to go to the catalog and you're going to scroll down in some way, hit the C and that'll take you closer. And you're going to scroll till you get inverse cotangent. You're going to hit enter. All right, we put in 3 and a decimal point, and we're getting these in radians, which is fine. So we have the 0.32175. Now we need the inverse cotangent of minus 3, so that's 2.8198, and I've listed them there for you. Now, if you're using an Inspire, it's a little easier because, remember, the Inspire has all of the trig functions and the inverses. So we do inverse cotangent of 3, and then we will do the inverse cotangent of minus 3, and we've got them much quicker than with the TI-89, but they both work very well. Now, let's solve some more using the quadratic formula. Then we'll use the calculator and inverse functions to complete the solution. Right? What's the first one we want to do? Let's solve the tangent squared of x plus 3 tangent of x plus 1 equals 0. Now this will not factor very well, so we're going to the good old quadratic formula. The tangent of x is minus 3 plus or minus the square root of 5 over 2. Now we'll find the arctangent using the calculator. All right, here we go. Let's go with the TI-89. Notice arctangent is one of the ones that we have on there. We need to very carefully put that minus 3 plus the square root of 5. Hit the square root button here. Okay, square root of 5. All right, a couple of parentheses, divided by 2. Put a decimal point so that we get a decimal answer. All right, now we also need, and we're going to go up there and get that, and we're going to add pi to it because there would be 2 with the tangent at, in this case, So now then we have to do minus 3 minus the square root of 5. So there's 1, and we add pi to it, or we can take it and add 2 pi. So now we're fixing it appropriately. And if you're having trouble following on the calculator, please stop the video and review, back it up, review. All right. And we need plus 2 pi to get the rest of those. And so here we go. We've got some answers. Okay, now you'll notice I paused at the end after using the TI-89 so that you could stay up with me. Now we're going to the inverse tangent using the inspire, and so we want minus 3 plus the square root of 5, all divided by, and we'll put in 2 plus points so that we get a decimal answer. And then we take that and we're going to add pi to it to get one of our answers, another one of our answers. And then we're going to take that answer. Whoops, I didn't want that answer. I meant to back up a little further, I believe. Okay, that one, and add 2 pi to it, and that gets us our a second answer. Now we're going to go up here, and that gets the two answers going around the circle for that to be plus the square root of 5, for 2, plus pi, and then we go back up here and get that, and say 2 times, and now we're going to have all 4 answers, which is, of course, what we want. So I'll pause here a moment and let you get those copied down, and then